Charging by friction. So we talked in the last video about how objects can be charged when they have extra electrons, they become negative, or when they're missing electrons, they become positive. But let's now start talking about some of the methods that are actually used to cause them to get extra electrons or take away electrons. So the basic idea here is if I have two objects, object A and object B, and I rub them against each other, so I'm taking object A and rubbing it up and down, then at the surface of these objects, this rubbing can cause these electrons to get knocked away from their protons, or to get knocked away from their atoms. What that means then is when these two objects are in contact with each other, they are effectively exchanging electrons. Some electrons are going this way, and some electrons are going that way. If this exchange of electrons is not even, then the amount of electrons on each atom, or on each material after the rubbing is complete, might not be equal to the number of protons in that material anymore. So let's say object A starts like this with four protons and four electrons. This is the initial. And object B we're going to do the same thing here, give it four protons and four electrons. This doesn't really represent four protons and four electrons. Really what we're representing here is the fact that they have the same number of each. And then we're going to rub those together. And let's just say that this material is material A is not as good at holding on to its electrons. That means that in the same amount of time that object B loses one electron to object A might lose two electrons to object B. So it's just not as good at holding on to those guys. So the sharing is not even because two electrons are coming to the right and only one electron is coming to the left. The final result of this would be object A would be down 2 electrons and have gained 1 back. So it started at 4, it lost 2, but got 1 back. So 4 minus 2 is 2, plus 1 means that it has 3 electrons in the final situation. The protons, of course, do not change, and now we only have 3 electrons, so that leaves us with a charge of plus 1. It wasn't as good at holding on to its electrons, so it lost some. It has a deficit of electrons, meaning it's positive. Alternatively, for object B, it still lost 1 electron due to the rubbing, but it gained 2 electrons. What that means then is it lost 1 electron, gained 2 electrons, so 4 down to 3 plus 2, it's up to 5 electrons after the exchange. That means that the 4 protons are now accompanied by 5 electrons, so we've got 4 positives and 5 negatives, and I end up with a charge of minus 1, or negative. Here, because object B is better at holding on to its electrons, it ends up with extra, or as we say, excess electrons after the exchange, and that means that it is going to be negative. Note here that this rubbing is not going to be strong enough. It's strong enough to cause the electrons to be removed from their atoms, but it's not going to be strong enough to move any of the protons. And so the number of protons that we have before and after in all cases is the same. Again, protons are big, heavy in the middle, they don't get exchanged. Electrons are light and on the outside, so they get exchanged a lot more readily. So that is how I end up with a positive and a negative object by charging by friction. Some materials that are better at holding on to their electrons are things like rubber. And some materials that are not as good, maybe something like fur of an animal or something like that. But we're going to go through how to tell which atoms are better at holding onto their electrons, are more likely to come up as negative, and which materials are not as good at holding their electrons and more likely to come up as positive in a future video. So that is charging by friction.